Hello everyone, today in the video we're going to be doing a bit of GCSE chemistry. We're going to be doing qualitative tests for ions. So before we start the video, make sure to like and subscribe and comment down below any questions that you have at the end of the video. And yeah, just enjoy and make sure to take some notes and attempt some exam questions after this. Let's get started. This next test is flame test, and this test for cations. Okay, cations are just positive metal ions. So you can either use the sodium hydroxide to test it, which is in a later or earlier video, or we can use flame tests. Now flame tests, what we do is we use a metal wire with a loop on it. Looped wire. And then we dip this wire into HCl. Dilute HCl, and this is to clean the wire off. Now the reason we don't use a splint is because we are going to put this wire in a flame, and if you put a wooden splint in a flame, it's just going to burn. So then we put it over the flame, and the flame will change color depending on which ion is present. Now the ions that could be present, we have lithium, which is a crimson color. This is basically red, but you need to say crimson to get the mark. You've got sodium, which produces a yellow flame, and these are ions, so they must have a charge. Potassium, which causes a lilac flame. Lilac, not purple, remember. And then you have calcium, which produces a brick red or an orange red flame. And then lastly, you have copper ions, which produces a blue-green flame. Green flame. And the way I remember this is as you go down group 1, you go down the colour of the rainbow. Red is first in the rainbow, yellow is after red, and purple is after yellow. Obviously not consecutive, but it does come like that. And then afterwards, you go to your group 2s and your transition metals. You have orange, red, then you have blue, green. So that's how I remember it. And that's all your tests. Now this next test is for cations. But this time, instead of flame tests, we're going to be using sodium hydroxide. So we're going to be adding sodium hydroxide to our solutions, and it will form a coloured precipitate. It's that simple. So the different ions we can have is Cu2+, and this forms a blue precipitate. We have Ca2+, which is calcium, and that will form a white. We have aluminium, which is a white as well. We have magnesium ions, which is also white. And lastly, we have iron. Now, iron can exist as two different ions, so it can be Fe2+ or Fe3+. If there's Fe2+ ions present, it forms a green precipitate, and if there's Fe3+ ions present, it forms a brown precipitate. Now, here's a question. How can we tell which one's aluminium, which one's magnesium, and which one's calcium, since they're all white? So what we do is we add excess sodium hydroxide. So we're going to add the same solution, but we're just going to add it in excess. And adding it in excess, what happens is the aluminium dissolves. The aluminium ion dissolves. But the magnesium ions and the calcium ions do not dissolve. And that's how we can tell between them. And that's all. The next test is for carbonate ions. The formula for carbonate ions is CO3 2-. You need to memorize this, as this is part of the spec in polyatomic ions. Now carbonate ions, it's quite an easy step. It's based on a reaction we already know of. This reaction is when a metal carbonate reacts with an acid, it turns into water plus carbon dioxide plus a metal salt. Now, so based on this, what we do is we add HCl. HCl is hydrochloric acid. It's highly acidic. Once we add HCl, from this we know if there's carbonate ions, a gas would be produced called carbon dioxide. So gas produced. Now we need to use a test for carbon dioxide. The test for carbon dioxide is quite simple. We bubble the gas through lime water. And if carbon dioxide is really the gas that is present, and that would be if the carbonate ion is present, then the lime water will turn from colourless to milky. And that is all. The next test is for sulfate ions. Now the formula for sulfate ions is SO42-. You need to remember this as it is part of your core polyatomic ions. Now sulfate ions, it's based on a reaction as well. So first we want to get rid of any other ions that are interfering, such as carbonate ions. To do this we add dilute hydrochloric acid, as this will get rid of any carbonate ions that are present in the solution. Then we're going to add barium chloride. After barium chloride, a white precipitate is going to form. If sulfate ions are present. Because, if you see here, this is a displacement reaction. The sulfate ions, they displace the chloride ions to produce barium sulfate, and that is a white solid. Barium sulfate is insoluble, and therefore it forms a white precipitate. And that's it. So the next test is for ammonium ions. The formula is NH4+. Now ammonium ions, what we do is we react it with sodium hydroxide. This is because sodium hydroxide has an alkaline ion in it, which is OH- ion. So this is going to react with the ammonium ions. So in an ionic equation, it will look like this. NH4 plus OH minus, and that turns into ammonia gas, which is NH3 plus H2O. Now we can see if this reaction happens because ammonia gas is produced. This is alkaline. So what we do is we get damp red litmus paper and we place this next to the mouth of the test tube. We don't dip it in, we just place it next to the mouth so the gas can rise up. And this red litmus paper will turn blue if there's ammonia. And that will show that there's ammonium ions present in the sample. Okay, so the last test you need to know is a test for halide ions. Now halides, they come from, this word comes from halogens, which is group 7. So halides is just a group 7 ions. So you have chloride, you have bromide, and you have iodide. Now to find these, there's displacement reaction again, and that's the same kind of thing as the sulfate ions, so it's pretty similar. So first of all, we want to remove any excess carbonate ions, any sulfate ions, so we're solely trying to look for the presence of chloride, bromide, and iodide ions. So to do this, we're going to add an acid. Particularly here, we're going to add nitric acid. Then you're going to add silver nitrate. The silver nitrate. Now the reason we add nitric acid is because if we add HCl, then it's going to add hydrochloric acid, which contains chloride ions. And we want to look and see if there's chloride ions in the solution. If we add HCl, that's adding chloride ions, so we're going to find chloride ions in it anyways, so it will just destroy our investigation. So we're going to add nitric acid instead. Now we're adding AgNO3. Now this is silver nitrate. Now these ions are going to react and they're going to displace the nitrate ions. So we're going to have chloride add silver, it turns into AgCl, or we'll have bromide and silver, and that turns into AgBr, or we'd have iodide and silver, and that turns into AgI. Now, so these are formed depending on which ion is present, and this forms a colored precipitate. So AgCl, if it's a chloride ion and it forms silver chloride, this is a white precipitate. If it's AgBr and then it will form a cream precipitate. And if it is silver iodide, then it will form a yellow precipitate. These are different colors that you need to know for your halide ions. And these are also displacement reactions. And that's all you need to know for tests for halides. So those are all the tests you need to know for GCSE chemistry. If you found this video helpful, make sure to like, subscribe and share for more content like this.